All right, let's get it started in here with these kinematic notes. Some of you may be wondering, but what are kinematics? Well, I'm glad you asked. Kinematics is just a way of using math and equations to analyze and predict the motion of objects. Let's take a look at our first example. We're going to analyze the takeoff speed of a plane on a runway at Midway or O'Hare Airport. Generally speaking, the takeoff speed of a plane is about 180 miles per hour, and the runway has a length of 2,000 meters. We want to analyze this problem to figure out at what rate must that plane accelerate to take off before reaching the end of the runway, and also how long does that take? When we're asked to figure out how long something takes, that's just asking us to figure out how much time is needed for that event to occur. Before we dive in and solve this problem, we need to make sure that we're approaching it the correct way. The first step that we want to note when looking at a problem like this is making sure that we have the correct units. So if we don't, we're going to have to convert to what we call standard units. And those would be meters, seconds, kilograms. So if we look over this problem, we're going to notice that we have 180 miles per hour. That is not the right units. And then we also have 2,000 meters. That is the correct units. So what we're going to need to do is we're going to have to convert that 180 miles per hour into meters per second. I'm going to set up my conversion ratios with the correct information. I'm going to put 1 mile on the bottom and 1,609 meters on top. Then I'm going to have 1 hour on top over 3,600 seconds. I'm going to wacha and then simplify. I get an answer of 80.45 meters per second. Remember, I'm asking that you guys round to 2 decimal places. Now that all of our quantities are in the correct units, we can get started with this problem. The next thing we want to do is draw a picture and choose an origin. Remember, we said an origin is our starting position. Okay, picture time. So I'm going to draw my runway right now. Then I'm going to draw my plane. Alright, it looks perfect. Got my little wheels right here. Got my nice little wing. I'm going to label where I'm starting at. So right there, my initial starting position, 0 meters. That would be my origin. And then how long that runway is. Well, if I look at my problem, I see that it is 2,000 meters long. And at the end of the runway, I got my little plane again. And this time, he's up in the air. He is flying. And of course, we got to put those smiley faces on our plane, fill up the plane, to show how happy Philip is to be part of this problem. Now we're going to look at step 3. And step 3 says that we need to list our variables in a table. So whenever we have a kinematic problem, we're always going to have 6 variables. And we're going to talk about what those are right now. One of our variables will be initial displacement, which is just referring to our initial starting point. Our next variable will be final displacement, and that's just referring to our ending point. Next, we'll have initial velocity, which is just asking us how fast are we moving in the beginning of the problem. Then we have final velocity, which is asking us how fast are we moving at the end of the problem. Another variable we're going to have is acceleration. And acceleration, like we said before, is how quickly are we changing our velocity. Our last variable is time, and like we said before, time is just asking how long does it take for an event to occur. All of these variables are going to be represented by their own symbols. Initial displacement is dO, final displacement dF, initial velocity VO, final velocity VF, acceleration lowercase a, and time lowercase t. Now that we know what all these variables mean, we're going to look at our problem and find out what are the values of these variables, if we know them or if we don't. Our first variable is initial displacement, meaning starting point, and we're starting at 0 meters. Our next variable is final displacement, meaning ending point, and we're ending at 2,000 meters. Our next variable is initial velocity, and this is almost always 0 meters per second because our object is usually starting at rest. Next, we have final velocity, and we see that our final velocity here is 80.45 meters per second. Then we're going to look at acceleration, which we don't know because that's what it's asking us to solve for. And lastly, time, which we also don't know because it's asking us to solve for that. Now that we've listed all of our variables and identified all of our givens and unknowns, All that we have left is to choose an equation and solve for an unknown variable. This is basic algebra, and we need to remember that when we're solving for a variable, we can only solve for one variable at a time. Some of you may be asking, what do you mean choose an equation? We haven't even talked about equations yet. Well, again, I'm glad you asked, because now we'll talk about a few equations. The first equation we're going to look at is dF, or final displacement, is equal to dO plus VO times t plus 1/2 AT squared. The next equation I want to look at is VF equals VO plus A times t. The final equation we're going to look at is a little bit more difficult, but it's VF squared equals VO squared plus 2 times A times parentheses DF minus DO. We're going to go ahead and name these equations, our first one being called Big Dog. The reason being, it's the equation that we're going to use most of the time. Our next equation is going to be called Little Pup, and that's because it's our smallest equation. Our last equation is called Shaggy Cat, and that's because it's terrifying. It has a squared, it has a parentheses, it's got some minuses, some pluses, so we really want to make sure that when we are using this equation, we're using it with caution and we're following order of operations. When picking an equation, we need to choose one that is only missing one variable. We're going to note, given that we're missing A and T, that the only equation that is missing only one of those variables is going to be Shaggy Cat. So that's the equation that we'll use. The first thing I'm going to do is write my equation. Always, always, always write the equation. Then I'm going to plug in my numbers. After I plug in my numbers, I'm just going to simplify and solve for my missing variable. Once I've worked out all the algebra and I've solved for my missing variable, I need to remember that these variables have units. So I need to give my acceleration the correct units, which is meters per second squared. Now that I've solved for acceleration, I'm going to take that value and put it in my table above. Lastly, we need to solve for time. Since time is our only remaining variable, we can use any equation that has time in it. I'm going to recommend that we use Little Pup because it's the smallest and easiest equation. Remember though, that when we are solving for a variable, we need to write the equation first with just the symbols. Then we can write the equation with the values for those symbols. All we need to do now is perform some algebra, and we'll find out that time is equal to 49.66 seconds. Again, I would prefer that you guys round to 2 decimal places. Remember to take that value and put it into our table above. We kind of skimmed over this, but step 5 is just to repeat step 4 until you have solved for all of your missing variables. And then step 6, remember to have fun. When you're doing these problems, smile, have fun, enjoy them. Alright, they're awesome. They're really, really cool. Lastly, just a few key things for you guys to think about. Don't forget your units. Always, always, always remember to put units on your answers. And then finally, if we were to take all the information that we just got and threw it into a sentence and describe what was going on, we would say the plane took 49.66 seconds to reach the end of the runway, given that it was accelerating at a rate of 1.62 meters per second squared.